I'm going to look at solving a system of 3 equations in 3 variables, and I'm going to use mostly the elimination method for this. The first thing that I want to do is I want to check to see if anything is already compatible where I can add the two terms together and get a 0. So as I look down through here, I don't see anything that I can readily find that goes to 0. So another idea I might try is to look at adding a couple of them together and be able to kind of reduce what I have. So 5 minus 4 is 1. Negative 3 plus 1 is negative 2. 3 minus 5 is negative 2. And then 31 minus 36 is negative 5. Looking at my second set, I'm going to do the same thing. Negative 4 plus 3 is negative x. Y minus 2 is negative y. Negative 5 plus 4 is negative z. And then negative 36 plus 35 is negative 1. That comes out to be a really reduced equation. And when I add these two together, I see that I am going to lose the x term. X minus x will be 0. And so that will be a step in the correct direction. So adding these together, I get 0 there, I get negative 3y here, and negative 3z here. Then I'll get negative 6 over here. So what I'd like to do is I would like to revisit these original equations and see if I can manipulate them to eliminate another x, and then use it in combination with this to try to solve for a y or a z. I'm going to have to multiply by a scalar this time to try to get compatible terms. Noticing that I have a y here, this tells me that this is a possible candidate for eliminating a y, since there's a coefficient of 1 there. None of these have a coefficient of 1 for the x, so I'm going to have to do a little extra work. I think what I'll end up doing is I will multiply this first line by a 3 and the second line by a 4. So I'm looking at a scalar of 3 here and 4 here. I'm going to pull those down to the below this to work on those. Alright, I've multiplied this line by 3, so that gives me this line. I multiplied this line by 4, that gives me this line. The reason I did that is because I want these compatible terms at the x here, because I want x to go away, because I want something with a y and a z to be able to use with this equation. And so I'm going to go through and add these up. I have 0 here. Negative 8 plus 3 is going to be negative 5y. 16 minus 15 is going to give me z. And I have 140 minus 108. And now I'm going to use this line and this line in conjunction with each other. What I can do here is I can solve either for y or z and then set them equal to each other using the substitution property. Since this doesn't have a coefficient, I think it's going to be easier to solve for z, so that's what I'm going to do. I'm going to move the y to the other side, so I'll have z equals 32 plus 5y. I'm going to bring the 3y over to this side, so I'm going to add 3y to both sides. So I have negative 3z equals negative 6 plus 3y. And now I'm going to divide through by the negative 3. So negative 6 divided by negative 3 is a positive 2. Positive 3 divided by negative 3 is negative 1. So we have 2 minus y here. So this one and this one I'm going to bring together. Since this is z equaling this, z is equal to this, by the transitive property, these two things are equal to each other. So I'm going to set them equal to each other. So 32 plus 5y is going to be equal to 2 minus y. And now I want to bring all my y's to one side and my numbers to the other. So I'll add y to both sides here, giving me 6y. And I still have the 32 at this point hanging out here, and this is equal to 2. I'm going to subtract 32 from both sides. So I'm going to have 6y is equal to negative 30. And now I'm going to divide both sides by the 6, leaving me with negative 5. So I found my first variable right here. Y is equal to negative 5. Now I can come right back in here and plug y into here and solve for z. So I'm going to do that. So I'm bringing that back here to this equation. So I'm going to have z is equal to 32 plus 5 times negative 5. So we have z is equal to 32 plus negative 25. So it's really 32 minus 25 here. So we have that z is going to be equal to positive 7. So this is my second term. And now I need to plug both this z term and this y term in to one of my equations so that I can solve for x. So let's go ahead and just look at this very first equation that we started with, and I'll plug in my y and my z into that. So I won't know my 5x because x is the term that I'm going to solve for. I'm going to have negative 3 times negative 5, and then I'm going to add 3 times my 7 that I found, and that's all going to be equal to 31. So I'm going to be able to simplify that and find what my x is. I'm going to erase this previous work here to give myself a little bit of room to simplify this and work out x. 5x plus 15 plus 21 equals 31. So I've just multiplied these together. Now I can add these two terms together. I'll have 36. And now I can subtract 36 from both sides. I'll have 5x is equal to negative 5. And then I'll divide both sides by 5. So I'll have x is equal to negative 1. So I have x, y, and z here now. So the solution for this system of 3 equations and 3 variables will be the point in a 3-dimensional space. And that is going to be the ordered triple negative 1, negative 5, and 7. And that will be our final answer. This is the point at which we get a common intersection. This is our x, our y, and our z coordinate. Cheerful calculations.